Kia ora Year 12 and Year 11. This is the first AS revision video that I've made in a while. I'm going to pitch this mainly for my A-level class, so it's going to be quite fast. If you're watching this from 12 MCA, just leave me a comment if there's anything you need me to go over a bit more slowly. A-level people, I am going to go a little bit slower than I would usually if it were a pure 3 video, so hopefully I'm going to get somewhere about right for both classes. So the other thing I'm going to start doing is using different colours for different types of videos. So if you see this ugly orange-brown colour, that means it's going to be an AS video to save you looking at the wrong ones. All right, let's look at the problem now. This is a 12 marker, so you can guess there are going to be lots of different bits to it. None of them are that bad. In the last bit, there are 2 quite cool ways to do it, so probably try and either fast forward to the end or watch the whole thing. We're given a function, and it's defined as follows for x greater than -1, and that's this curve shown here. We have to find the first and second derivative, and then we have to verify that the function has a minimum value at x equals 0. So this is slightly easier than if it just said to find the stationary points, because we're just going to have to check that conditions are satisfied at this value. So that's quite good. And that's 4 marks. Right, so you can see it definitely feels like a pure 1 paper, not a pure 3 paper. Secondly, we're given 2 points on that curve. We're given their coordinates, and we have to find the distance between them. So that's going to be Pythagoras. And then we have to find the area of the shaded region. So we're going to do that by integrating. But again, 2 ways to do that. One is much smarter than the other. I want you to be comfortable with both. So let's get going on the differentiation. I'm going to pause the video and do that without talking, because that should be pretty straightforward. Okay, so there we go. We've got the first derivative and the second derivative. Leave me a comment if you've got trouble with those, anyone watching from the AS class. Now, what we have to do is to verify that the function has a minimum value at x equals 0. So for a minimum value, we want to have the first derivative being equal to 0 and the second derivative being strictly positive. So let's chuck in x equals 0 into the 2 functions and see what we get. Now, we're showing something, so we don't just want to write down equals 0, so that hasn't really shown anything. So the substitution needs to be really clear. All right, so it's 2 minus 2 times 0 plus 1 to the -3, which is 2 minus 2 over 1, which is 0. So we've got a stationary point. Pretty much, we have to be careful. We might have a stationary point. We have to check the second derivative. And f dash dash of 0 is equal to 6 times 0 plus 1 to the -4, which gives me 6 over 1, which is greater than 0. So we have got a minimum, right? Now we've got that minimum because we've got 2 conditions. We've got the first derivative equals 0 and the second derivative strictly positive. Don't make the mistake of thinking that just because I've got a second derivative being positive, I've got a minimum, right? Because it doesn't mean that. But if we've got the first equal to 0 and the second being positive, then we do have a minimum. So we've done the first 4 marks, so that was good. And the next bit is also pretty easy. We have to find the distance between the 2 points, and we're going to do Pythagoras to do that. So A is -1/2, 3, and B is 1 and 2 1/4. So the distance between those 2 things is equal to the change in the x value. So I'm going to start with this one. 1 minus -1/2 squared plus the change in the y value squared. Turning this into an improper fraction, we get 9 over 4 minus 3, which is 12 over 4 squared. That gives me the square root of 3 over 2 squared plus -3/4 squared. So I get 9 over 4 plus 9 over 16, common denominator, so 36 plus 9. I know some of you are rolling your eyes at how many steps I'm doing. This is to make sure everyone can see what I'm doing. And if I were doing this for myself, I would not be skipping many of these anyway. I would definitely do that one. I'd do that one to avoid mistakes. I'd do that one to avoid mistakes, and then I would still do that one. So actually all of these are ones that I would put in, right? So we get root 45 on 4 is my lovely answer. or my calculator answer to 3 significant figures is 1.68 to 3 SF. Okay, that leaves us the last question, which is the interesting bit. Well, relatively. Now, we have to find the area of the shaded region. So there's a clunky way to do this, right? Which is that if I've got two curves and I want to find the area between them, I take the top function minus the bottom function, and I do this. So I do the integral of the top one minus the bottom one. And we can do that here. So to do that, what I have to do is to find the equation of this line. I'm going to go through that because it's a very useful skill anyway. And then we've got the equation for the bottom function here. But maybe you can stare at this and see a smarter way to do it. And it's because this is a straight line. And that often makes things easier. So look at what happens if I draw in, very badly, some straight lines. Right, these straight lines. So this shape here is a trapezium. And the area of a trapezium can be found without any complicated maths, just a little formula from year 9. So if we find the area of the trapezium, and then we subtract from it this area, then we'll have our answer. So that's my favourite way, but I'm going to make you suffer through the long and boring way first. So you might want to forward the video. So we've got AB. We know the distance from A to B. Let's look at what those points were. Right, so to find the equation that goes through those 2 points, I need to find the gradient and then substitute in. So the gradient between A and B is the change in y over the change in x, which is this. Change in y, and just be careful with your negative signs. So here we've got negative 3/4 over 3 on 2, which gives me negative 3 over 4 times 2/3, giving me a nice gradient of negative 1/2. Now we're going to sub in to, well, my favourite now is y equals mx plus c, and I'm going to use the point 1 and 9/4. So we have 9/4 is equal to negative 1/2 times 1 plus c, giving me c of 9 over 4 plus 1/2, which is, let's see, 11 over 4. So the equation of that line is negative 1/2 x plus 11 over 4. So at this point, unless you've spotted the trapezium thing, you're probably feeling quite good about everything because we know what to do. Right? We've got the equation of the top line and we've got the function for the bottom one. And we know our limits of integration. It's the x value here and the x value here. Right, so let's just work through that integral. So the area will be the integral from 1 to negative 1/2. Top function minus the bottom function, 2x plus x plus 1 to the negative 2 dx. So cleaning that up, we get negative 5 over 2x plus 11 over 4 minus x plus 1 to the negative 2 dx. Now we're going to integrate that. We'll get negative 5 over 4 x squared plus 11 over 4x. Leave a gap to check this, but it's going to go up a power, right? So this is for year 11s, right to the power of negative 1. When I differentiate, I'm going to get a minus, which is what I want up here. So this needs to be a plus. Hopefully that all made sense. Now when we substitute in here, we just got to, you can see that this is feeling like a lot of work, right? So that's negative 5 over 4 plus 11 over 4 plus 2 to the negative 1, which is 1/2, minus negative 5 over 4 times 1/4 minus 11 over 8 plus 1/2 to the negative 1. Yuck. I know you guys are going to get your calculators out to do this, but we can clean it up and we get 6 over 4 plus 1/2 plus 5/16. Okay, this is just really quite tedious now. So minus 2. And we do all of that. The common denominator over 16. But you're going to use your calculators and you end up with 27 over 16. Right, so now we're going to do the trapezium way, which is just so much better. But it won't always work. So we need to understand that top function and bottom function stuff pretty well. So let's now do the area of the trapezium. What have I got here? Trapezium, I must have a perpendicular height here. So this distance is 3 over 2. Right, so it's the width, it's the difference in those coordinates. This height is 9 over 4, and this height is 3. So area of trapezium, whoops, A is equal to the average of the two heights times the width, or whatever we call it. So that's a half A plus BH is the formula. That gives me 3/4 of 21 over 4, which is 63 over 16. Then we need to subtract this integral. You can see that this is much, much easier to do than the big mess we had above, which wasn't even fun integration, it was just boring. What does that give me? Well, substituting in, I get 1 minus 2 to the negative 1, which is a half, minus, this is negative 1/2 squared, so that gives me 1/4. I wonder if anyone's still watching. Here, 1/4 minus negative 1/2 plus 1 to the negative 1, giving me 1/2 minus 1/4 plus 2. So that equals 9 over 4. Turning that into something over 16, I get 36 over 16. Therefore, the total area is equal to 63 over 16 minus 36 over 16, which is 27 over 16, just as it was 3 or 4 minutes ago. So there you go. So just make sure that you note down anything that was new in that exam question. The biggest thing that I think you won't have seen is the trapezium thing. I'm sure lots of you did, but probably quite a few of you didn't. And other things to note in here that were useful is that verify means that we can save some work because we can substitute this thing in here. And this one here is just Pythagoras, right, which probably will come up somewhere in the AS paper, either here or when you're working with the magnitude of a vector. All right, that's all from me for tonight. Thanks for watching, and leave me some comments if you need any help.